Hello, grade 9s. I wanted to talk a little bit more about this idea of solving a system of linear equations or linear relations, because it's not the easiest thing, and in particular it's difficult if to choose a scale in some cases, not in this first example that we did in class, but in the second example I'll show you shortly. So this was the one we did in class. We're told here, we were given some information about the problem. Ted charges $15 per hour. There's no initial value here. Sally charges a base fee of $20 plus $10 an hour to cut grass. Here in the question, first part of the question, it tells us to go up to 6 hours. So that's a big advantage. You don't have to figure out what scale to use or what values to use for time. We're just going to use 6 hours. So here are our two tables. For Ted, first of all, it's a direct relation because there's no initial value. We have the independent variable in the first column and go from 0 to 6 as we're asked to. And in the second column, we go from 0 and we figure out what the charge is using the information given. So we're told $15 per hour. So after 1 hour, it'd be $15, 2 hours, $30, and so on. The rate of change is $15 per hour. So these numbers will go up by 15. For Sally, now Sally's is a partial variation, so we have an initial value of $20, and the rate of change is $10 per hour, so these numbers go up by 10 as these numbers go up by 1. Even already from the tables, we can see that at 4 hours the cost is the same, so that's our break-even point, or our point of intersection. So we create the graph, so we choose a scale. I've chosen 1 square is $10 for the vertical axis scale, which makes the values from 0 to 90 fit on quite nicely. And we go from 0 to 6 for the time. I've labeled my axes time in hours, charge in dollars, and I've drawn the two lines. So the red line here is for Ted, starts at 0, and the green line is for Sally, starts at 20. So the point of intersection here is after 4 hours, $60. They both charge the same amount. So when we're making decisions from a system of linear equations, there's always a different decision depending on which side of the point of intersection you're on. So from 0 to 4 hours, so all the way between 0 and 4 hours, Ted's graph is lower than Sally's, so Ted is cheaper. At 4 hours, they're both the same, and after 4 hours, green line here, so that Sally's line is lower, so Sally is cheaper. So we would say, if we're going to make some conclusions about this, I'm just going to scroll down, we'd say Ted is cheaper from 0 to 4 hours, Sally is cheaper for more than 4 hours, and at 4 hours the cost is the same. One additional thing to add here is this part in E here. There is an algebraic way to find out where the point of intersection is. What you do is you'd say the costs are the same, or the dependent variables are the same at the point of intersection. So if you use the equations for each of the two people in this case, and then solve for, in this case, t, we get t equals 4 hours. So you can always do this. You can use this algebraic approach to find a point of intersection, and that's a really valuable thing to do, is to find a point of intersection if you are not sure what scale to use or what to go up by in your table of values. So let's take a look at this second example now. Here in this example, we've got two fitness clubs. We've got Healthy Fitness Club here, which has an initial value of $150 plus $20 per month, so that's a partial variation. And then First Fitness has a $200 membership fee and $15 per month. It's also a partial variation in this case. Just to review independent and dependent variables, the independent variable is the number of months and the dependent variable is the cost. So the cost depends on the number of months. So that's the way to think about it. If we were going to create equations for these two, then for Healthy Fitness Club, the cost would be 20. That's the rate of change, $20 per month, times the number of months plus 150, which is the initial value. For First Fitness, the cost is $15 per month multiplied by the number of months plus $200 is the initial value. So I've declared my variables over here. So we're going to go to creating a table of values and then making graphs. But again, we want to find out where is that point of intersection so we know what to go up by in our table, or so that we know what to use for a scale for our graphs. So you could use algebra just like in that previous example. So if I set this equation equal to this equation and then solve for m, to find m, I should be able to find it that way. Here's another way to think about it. I'm just going to shift this up a little bit here. If we look at the difference in the initial values, so how much different are the initial values? So one is 150, the other one is 200. So the difference in the initial values is $50. And then we look at what is the difference in the rates of change. So one is 20, one is 15. So the difference in the rates of change is $5 per month. So we've got a difference in values of 50 and a difference in rates of 5. So if we divide the difference in the initial values, the 50 over here, by the difference in the rates of 5, we would get 10 as the answer. So that's 10 months. So if we use that approach, we can, or either approach, we find out that the point of intersection is going to be after 10 months. And so we know we need to go up at least until 10 on the horizontal axis, or at least 10 for the independent variable in our table of values. So that's what we do here. So I chose to start at 0 and go up by 2's until I get to 12, which is just past the intersection point here at 10 that I just found. So I'm going to go up by 2's here, and then I calculate either using my equation or just using logic. I calculate what would the cost be for each of those values of time for each of the two clubs. So starting value of 150, and this one, the rate of change is 15, but since we're going up by 2 here, we'd go up by 30. The rate of change for Healthy Fitness Club is 20, so instead of going up by 20 here, we go up by 40 because we're going up by 2 here. So these values increase by 40. So it's $40 every 2 months. And in this case, the rate of change is 15 for First Fitness. I see it over here. So for every 2 months, this one will go up by $30. And we see that again at 10 months, they're the same. On the graphs, we can show that too. So here we have, I used 2 different colors for my graphs just to keep them separate. I've chosen a scale that goes from 0 to past my biggest value in my my table for cost, and from 0 to 12, which is where I went from in my time column over here. So I plot the 2 graphs. They're going to be straight lines. They're both linear relations, so they'll definitely be straight lines. The point of intersection is here after 10 months, $350. So the last thing to do then, of course, we make sure that we label our axes, cost in dollars and time in months down here. And our conclusion would be Healthy Fitness Club is cheaper up to 10 months. So if we see from 0 to 10 months here, this blue line is lower. So that's Healthy Fitness. They're cheaper up to 10 months. And First Fitness, which is the green line here, is cheaper once we go past 10 months. And at exactly 10 months, they're both the same. That's the point of intersection. So that summarizes how to solve a system of linear equations, which is kind of the most complex or complete part of linear relations that we've been studying. And just to review then, the key thing is to figure out at what point are they both the same. So we kind of somehow got to figure out, or kind of at least estimate, where is this point of intersection here, so that we know how to set up our table of values or what scale to use for our graphs. In every case, there's going to be somewhere where one is better than the other and another place where the other one is better. So that's kind of how these problems always work. So feel free to review this video over and over until you get the idea, and you can always try with some of the review problems that I've assigned or the tickets that we've used in class.